Hello students, now it's turn to talk about paper 2 of JEE Advanced 2018. So starting with the first question, for any positive integer n, define fn from 0 to infinity to r as fnx equals summation over j from 1 to n tan inverse 1 upon 1 plus x plus j into x plus j minus 1. Then based on this data, some options are given, like they are asking for summation tan inverse fj0 or summation 1 plus f dash j0 or two more options based on the limiting values. So first, what we need for this question, we need to simplify this term summation tan inverse 1 upon 1 plus x plus j into x plus j minus 1. So let's simplify this function. Fnx equals summation j equals 1 to n tan inverse 1 upon 1 plus x plus j into x plus j minus 1. This can clearly be simplified as tan inverse x plus n minus tan inverse x, right? Now we are looking for the values of this function n at x equals 0 as per the option 1 and 2, but when we look at the given domain, which is 0 to infinity open at both ends, the first option is talking about f at x equals 0, but 0 is not in the domain, meaning clearly it is not the correct option. Maybe once you put x equals 0, this may give the similar answer as 55, but this is not in the domain. Similarly, option 2 is not valid as x equals 0 is not there in the domain of the function. Now moving to option C and D. C and D are talking about tan fnx under the limit x approaching to infinity. So let's talk about this part. Limit x approaching to infinity fnx is equal to, this simply gives us, we can also write this term as limit x approaching to infinity. This term tan inverse x plus n minus tan inverse x can further be simplified as tan inverse, just apply tan inverse x minus tan inverse y, that gives you x plus y, meaning simply n in numerator divided by 1 plus x into x plus n. Right. Now when we apply limit x approaching to infinity, this simply gives me this term approaching to infinity, meaning entire term is approaching to 0. So this becomes 0. Alternatively, you can also check from here tan inverse approaching to infinity minus tan inverse approaching to infinity. So going to become pi by 2 minus pi by 2, but here we simply get it directly as 0. So option C, as it was given, limit x approaching to infinity tan f and x equals 1 by n, is also not correct. Moving to option 4, limit x approaching to infinity sec square f and x. So limit x approaching to infinity sec square f n x. This is limit x approaching to infinity 1 plus tan square f n x. When limit x approaching to infinity tan fnx we talk about, it was 0. So clearly this entire limit is approaching to 1, meaning that option D, which also says the same thing, is equal to 1, is the correct option. So correct answer for this question is option D only. So this point is clear. Okay, moving to the next question, that is question number 2. Question number 2 says, let T be the line passing through the points P and Q. 2 points are given. Let F1 be the set of all pairs of circles S1, S2 such that T is tangent to S1 at P and tangent to S2 at Q. So, this is the tangent at P and for S2 at Q. Also such that S1 and S2 touch each other at a point, say M. So, the two circles are also touching each other. Let E1 be the set representing the locus of M as the pair S1, S2 varies in F. So, this is important thing, E1. E1 is the set representing the locus of the point M. Let the set of all straight line segments joining a pair of distinct points of E1 and passing through the point R be F2. Let E2 be the set of midpoints of the line segments in the set F2. We are talking about midpoints in the set F2. Correct? So, this gives you E2, another important set. Then which of the following statements are true? 4 options are given based on it. Options are like 4 points are given, these are lying in E1 or E2. So, important terms, that is point P and Q, let us write it down, minus 2 comma 7 and 2 comma minus 5. Point P minus 2 comma 7, point Q 2 comma minus 5. Now, considering the given statements and these 2 points, we can trace the figure as this one, the line that is T, it is passing through 2 points P and Q. The circles are touching each other at a point, say M, it is given. Now, if I consider the angle QMP, this is clearly 90 degree. This angle QMP is pi by 2. When this angle is pi by 2, P and Q, the coordinates are known to us, we can apply the formula M1 M2 equals minus 1 to get the locus of point M. So, it gives us, let us consider x1 y1 as coordinates for M, P known to us minus 2 comma 7, Q known to us 2 comma minus 5. So, we get y1 plus 5 upon x1 minus 2 multiplied with y1 minus 7 upon x1 plus 2 is equal to minus 1. Simplifying, it gives us the locus of M as x square plus y square minus 2y minus 39 is equal to 0. Correct? This one we get as the locus of M as per the given statements. Now, the question further says, let E2 be the set of midpoints of the line segments in set F2. Correct? So, let us consider the midpoint be h comma k. Midpoint let us consider as h comma k. We can find the equation of chord whose midpoint is known to us. The equation of chord is simply hx plus ky minus y plus k minus 39, that is t, is equal to S1. S1, that means h square plus k square minus 2k minus 39. It is passing through the point 1 comma 1, it is given in the question. It passes through one comma 1, correct, as it is mentioned in the question here. It is passing through the point R 1 comma 1, correct. So, based on that we will get the locus for E2, the set E2. Then from there we will check all given 4 options and will try to conclude the required answer. So substituting 1 here, we get h plus k minus 1 minus k is equal to h square plus k square minus 2k. That is all. We need the locus of hk. Therefore, locus of h comma k is, simply replace hk by x and y to get the required locus. So, it is x square plus y square minus x minus 2y plus 1 is equal to 0. So, this is the required locus, this is the set in E2. Now, checking with 4 options which are talking about points in E1 and E2. When we put these points in locus we obtained as E1 and E2, then we observe that option D is correct, as it is saying the point 0, 3/2 does not lie in E1. Now, option A and B are pretty interesting one. Option A says the point -2, 7 lies in E1. Point -2, 7, when we put on the locus obtained, it is satisfying, but still this point is not lying in E1. Why is so? Because point -2, 7 is point P. So, when you say M is coinciding with P, so it will not give us the required locus, that is the circle. So, clearly we can say the point is not lying in E1. So, this is not the correct option. Point B is also interesting one. The point 4/5, 7/5 does not lie in E2. When we put this point in the locus obtained for E2, it is satisfying, but this point is coming as the midpoint when -2, 7 is taken as one of the point for E1. -2, 7 is not in E1, so clearly it will also not lie in E2. So, this is also correct. Hence, the correct answer for this question comes out as option B and D. So, this is clear. Okay, now moving to the next question, that is question number 3.